Welcome to the video on mean. Let me get the title up here on our board. The mean. What is the mean? Let me try to clear that up a little bit. That's a little messy. What is the mean? Well, again, this is a measure of central tendency, and so if you have not seen the video on central tendency, I would suggest you stop now and go watch that particular video. But the mean is essentially, the way I think of it is just the balance point or the balancing point for the distribution of scores. Distribution of scores. So I've again kind of preloaded some data up on here, just that simple data set that we've been working with in terms of the mode and the median. And so we have a random variable x here, this variable right here that produces this set of raw score values of 10 individuals and how many years they have been employed at whatever the institution is. And so how do we actually find the mean? So building on the summation notation concept, we're going to write the equation for this. Well, the mean of a sample, and we can kind of consider this random variable x to be a sample of scores, and we'll talk about sample and population differences later on. The population mean, by the way, is denoted by the Greek letter mu, but we're not going to be interested in this particularly right now. We're going to use x bar, and x with a line over it, which is x bar, and x bar is a sample mean, and the sample mean is calculated again using this summation notation. The general form of it is sum from I equals 1 through n of those x sub I scores divided by n. Pretty straightforward for us. Going back and kind of to the summation notation video, let's just kind of do this kind of long form here, where we build in our I and then our x sub I. Let me put a long line in here because we're going to have 10 scores here. So 1, 2, 3, 4, 5, 6. Lengthen this a little bit. 7, 8, 9, 10. Okay, and then we're going to have our, and I'll do this I guess over here in red, we're going to have our x sub I. So at I equals 1, I is a 7. At I equals 2, this is an 8, and so on and so forth. I don't have to keep doing those. So we have 7, 8, 8. The fourth score is a 7. The fifth score is a 3. Sixth score is a 1. Seventh score is a 6. 9, 3, and the 10th score over here at I equals 10 is an 8. So what are we going to do? Long form, what does this, actually we can rewrite this equation. Let's just do that. So this general kind of form here could then become x bar equals the sum of I equals 1 through, because we have a known amount of scores here, through 10, right, x sub I divided by n. Now this expression, the long kind of way of this then becomes 7 plus 8 plus 8 plus 7 plus 3 plus 1 plus 6 plus 9 plus 3 plus 8, right? And we want to do, this is taking care of the numerator piece here, and then all of this is going to be divided by n, which is 10. And so if you add this up on the top here, you're going to get, this is going to be 60, and you're going to get divided by 10, which will give us our solution, which is the integer 6. Okay, and so 6 then becomes this balancing point for the distribution of the scores. So again, this kind of complex looking summation notation equation really is just another way of kind of shorthand saying we're summing all the scores of variable x, all the raw scores on variable x, these x sub i's, and dividing by the number of scores in that particular distribution, which is this index of summation piece. So there was 10 of them. And just another way of thinking of these. Let me just kind of show you how I kind of do this and kind of give you kind of a statistical intuition here. And I'm not the best artist by any means here, but I'll try to do my best. So I kind of think of it as a beam or a balance beam. That last piece didn't go so well. Let's try that. Let's try this one more time. It's hard to draw a straight line sometimes on this bamboo tablet, but better. Okay, so I kind of think of it as this balance beam. So if we put this, somewhere in here we have to put kind of the fulcrum. Right, you're going to have scores stacked on either side. How do we stack them? Well, let's kind of think of this as a number line too. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 9 was the highest score that we had in our data set. All right, so let's look at it this way. So how many ones did we have? Well, we had one. Let's do this, and I guess we'll go back to pink. We had one here, right? So we're going to put one box here on our balance beam. We had no 2's in the data set. We had 2 3's. Right here was a 3, and right here was a 3. So let's put 2 boxes on top of the 3. We had no 4's in the data set. We had no 5's in this data set. We had 1 6 right here in this data set. So let's put 1 box on top of the 6. We had 2 7's here and here. Here's the 2 boxes for the 7's. We had 3 8's. 1, 2, 3, and we had 1 9. All right, so the way I think of the mean then, and this is just trying to give you some kind of statistical soul or some intuition on what this value of 6 really means, is now you're having to put a fulcrum or a balance point, right? So where would you slide, if we were going to put a kind of a triangle to signify, how would you balance this? You would put that triangle right here under the 6, and that, these scores that are way out over here, even though there's fewer of them, they have more influence, right, than these scores that are closer to this particular value. And so you have to, kind of move this triangle back and forth to find that balance point, and that's where it is for this particular data set. Another way to think of this, and this is just another way that's kind of introducing us to the concept of a deviation score that would be coming up, but this fulcrum point, the 6, the balance point, that is the mean here, is a point such that any other score that is deviated from it, the deviations will kind of sum to 0. Let me kind of show you what I mean here. So if you take this one right here, this box right here represents a 1, and if you take that from the 6, which is the mean, right here is our mean, then you would have -5 over here. We have 2 3's over here. If you took 3 minus 6, you would have 2 -3's here. So you have a -3 here and -3 here if you deviate this raw score 3 from this raw score or mean score of a 6. Okay, 6 minus 6 here would give you a 0. 7 minus 6, you would have a 1 here as your deviation score. You'd have a 1 here. So essentially what we're doing, we're taking an x, a raw score, and subtracting it from the mean here. That's what we're kind of doing. And what would you have here for 8? So you take 8 minus 6. This would give you a 2, a 2, and a 2. And then a 9 minus 6 would give you a 3. We'll count up all the deviations on this kind of right-hand side, or the positive side of the mean. What does that give you? Well, we had, 1 plus 1 is 2, and then we have 3 2s. So, these 2's right here added on to 2, 4, 6, that gives us 8. And then that 8 added on to this 3 gives us, we have a total on the positive side here of plus 11. And then if you take this score over here, this 1, which was a negative 5 from 6, okay, then you add it to these two negative 3's, then you have a minus 11. Well, let's kind of fix that piece. You have a minus 11. Let's try that one more time. You have a minus 11. And so what you'll see then is the mean is not only the balance point, but it's the point at which the sum of the deviation scores will equal 0. And you can see that here, negative 11 plus 11 equals 0. So you know that 6 is the right balance point. So it's just another way, kind of an alternative way of thinking of the mean. And so go back over, think about the actual expression in the equation here. That's it. Just think of it as the balance point of the distribution of scores. Thanks for watching the video.